All right, so let's begin looking at parallel and perpendicular lines. So just as usual with these video notes, feel free to pause at any time. I'll probably go through things a little quicker and then just pause when you need to write your notes. Okay, so by the end of this lesson in particular, we're going to just determine if lines are parallel or perpendicular and be able to write equations based off that kind of information as well too. Okay, so first of all, let's just go over some definitions. So what is a parallel line? Well, we know parallel lines are two lines that never cross. And we can determine based off an equation of a line if they're parallel based off their slope. So if they have the same slope, then they'll be parallel. So that's going to be the key, looking at their slopes, checking if they're the same. What about perpendicular? So a perpendicular line, two lines are perpendicular if they cross at an angle of 90 degrees. So let's say you have one line like that, another line, those two are at a 90-degree angle, as compared to parallel where, they're just straight lines beside each other. You could think of it as their product of their slopes is -1. So take one slope, let's say your first slope, and then multiply it by your second slope. That should equal -1. Usually we don't actually, let's say, think of it in that way. What we do is we use the second part. So we have one of our slopes, and then we just check, is the other slope the negative reciprocal? And that's going to be sort of the basis of checking whether two lines are perpendicular. Okay, so let's just practice finding negative reciprocals. So we have to think back to fractions. First of all, what is a reciprocal? And then what does it mean to be a negative reciprocal? So remember, from fractions, a reciprocal is just flipping the fraction. So if we have 3/2, that becomes 2/3. But we also need to make it negative, so that would just become -2/3. All right, what if we have a number that's not a fraction, like 2? Well, we could still think of it like a fraction, write it as 2/1. And well, if you take the reciprocal of 2/1, that becomes 1/2, and then just stick the negative out in front. So -1/2. And we can keep this up. So again, you could think of -1/1 as a fraction. That just becomes 1/(-1). But then just stick, let's say, another negative sign. What you'll see though is if you already have a negative number, that's just going to become positive. So you'll have 1/1, which again is just 1. So in the end, -1, the negative reciprocal is just 1. And what you'll see here, we found that -1 negative reciprocal is 1. And here we're asking about the negative reciprocal of 1. And well, let's just calculate this out. So take the reciprocal and take negative. You'll see it's -1/1, but it's just -1. So in fact, numbers and their reciprocal are sort of paired together. So if you take the negative reciprocal of -1, you get 1. If you take the negative reciprocal of 1, you get -1. So they're sort of paired up in that way, so you can go back and forth between the two. And that's going to be very handy is whenever you're calculating the negative reciprocal, you can always just, if you start off with a negative number, your negative reciprocal will just be a positive number. If you start off with a positive number, you'll get a negative number. Okay, so there's some negative reciprocals. What about this one? What if you had a slope? We can have an undefined slope. We've seen that before. What would the negative reciprocal be of that one? Take a moment, think about it, pause, and then when you think you have an answer, or if you just want to find out, continue. All right, so for this one, what might be helpful to remember is that the reason why we had an undefined slope is when we were doing like rise over run, what had happened is, I'm using the number 1 as your rise, it could be anything, but we had a run of 0, and that's because this came from a vertical line. So in a sense, we had a fraction divided by 0. That's why it was undefined. But if you, let's say, flip this fraction, that would become 0 over 1. And I mean, you could take the negative of that. But this is just 0. And so in fact, the negative reciprocal of undefined is just 0. And if we think of that in terms of actual like graphing lines, well, undefined means you have a vertical line. Exactly 0 means you have a horizontal line. And so those two we do know are perpendicular to each other. They make 90 degrees angle. Okay. Next, let's just practice putting that into practice. So which pairs of lines are parallel and which are perpendicular? Okay. So first of all, let's just do the parallel column. So if we want to check things that are parallel, look at your given slope. So let's say the first one is 3. Are there any other lines with slope 3? And you can see, well, the one in D has that line. So we can say A and D are parallel. Okay, let's continue on just to see maybe there's another pair. 2, is there anything else with a slope of 2? Well, we've 0.5 and negative 2. Just be careful. If the signs aren't the same, they aren't parallel. They have to be the same sign. And so we don't have any more parallel ones. Let's try perpendicular. So what I'm going to do is just to the side, let's just quickly compute some negative reciprocals. So if we have 3, that becomes negative 1 over 3. 2, that's going to become negative 1/2. 0.5, okay, 0.5 is a tricky one. 0.5 you can think of originally as 1 over 2, which would then become negative 2. And look at that. We just wrote down negative 2, and that's down there as well too. So those two actually match. As in 1/2, its negative reciprocal is negative 2. So C and E are in fact perpendicular. So 0.5x plus 2 is perpendicular to negative 2x minus 6. And in all of these, the numbers that you have at the end here, your y-intercept, those don't matter. They could be anything. All that matters is your actual slopes. All right, here's a quick question to test yourself with. All right, and let's go through it. So are these two lines parallel, perpendicular, neither, impossible to tell? So let's first of all just compare them, the two slopes. And in this case, 2 and negative 3 are not the same, so it's definitely not parallel. Let's take the 2 and check its negative reciprocal. So 2 is going to become, 1 over 2 and negative, but that is definitely not equal to negative 3. So it's also not perpendicular since its negative reciprocal isn't the slope of the other one. Now, is it neither or impossible to tell? Well, we just proved that it's neither parallel or perpendicular, so it's possible to tell it's neither of those. And so, in fact, it's C. Okay, so now let's actually try to find some equations using information about parallel and perpendicularity. It sounds like a word, so I'll say it. Is parallel, okay, so we want to determine an equation that's parallel to this line and goes through the point 2, negative 5. All right, so what we need to do to find out an equation, again, if we're writing an equation, we're going to write something in y equals mx plus b, so we need to figure out what's m and what's b. So we can figure out what m is based off the fact that we're looking for something parallel to that given line. So we have this given line, and let's just look at that given line. We have an m value of negative 3 in that given line, which means then our m value in this new line we're drawing or creating is also going to be negative 3 because they have to be parallel, so they have to be the same. Okay, so right now we have an equation y equals, let's say, negative 3x plus b. So now how do we figure out b? Well, we can substitute in this point that we're given into the equation. And why is that going to work? Well, let's see. So where you have 2, substitute that in for x. So sub 2, negative 5 into the equation. So 2 goes in for x, and negative 5 goes in for y. So you'll have negative 5 equals negative 3 times 2 plus b. I'm just going to swing that around over here. So you'll have negative 5 equals negative 6 plus b. We're just solving for b. So remember, using good old opposite operations and such, to get that negative 6 away from the b, add 6, and that will become 1 on the left-hand side is equal to b. So then that's going to make the equation y equals negative 3x plus 1. So there we have it. We've used both those pieces of information to create that equation. Let's take a look at another one. Well, just a quick little question for you to think about. So determine the equation of a linear relation which meets the following criteria. So a linear relation that represents direct variation and is perpendicular to y equals x. So which of those follows that? All right, so hopefully you had a moment to think about that. All right, so we're given the line y equals x. So if we want something that's perpendicular, well, let's first of all check what is our original slope. Our original slope in this line up here is just 1 because we have, in a sense, a secret little 1 in front. And so if we want something perpendicular, the negative reciprocal is just negative 1. And, well, if we look at all the equations we have here, we only have one that has a slope of actually negative 1. And so it's y equal to negative x. Okay, again, we're determining some equations based off information, so let's take another look at this. So we want to make one that's perpendicular to y equals negative 2x plus 13 and has the same y-intercept as 2x plus 3y minus 12. Okay, so let's just use that first bit of information. So we're going to determine the slope using our first part about it being perpendicular to this line. So we know this line has slope negative 2. So we want the negative reciprocal of negative 2. So I'll just write that down. Negative reciprocal of negative 2. Okay, and what is that? Well, flip it over. It's going to become 1 over negative 2. But remember, if you're taking the negative reciprocal, the sign switches, so instead of a negative number, we can just leave it as positive. So the negative reciprocal is just 1 over 2. So our equation is going to look something like y equal to 1/2 x plus b. So we just need to figure out, well, what is b? Okay, so unlike the first example we looked at, we don't necessarily have a point to substitute into this equation to solve for b. What we need to do is we need to use this other equation, determine its y-intercept. And how we can do that is we can basically rearrange that. Well, okay, you know what? I was going to say we could rearrange it into y equals mx plus b form. That's totally fine. But I've just come up with another way. So to determine the y-intercept, well, what does the y-intercept mean? The y-intercept means what is the value of y when x is equal to 0. So what we can do is just sub x equal to 0 in. Okay, so if we have that equation, 2x plus 3y minus 12, we sub in x equal to 0, so it'll just be 2 times 0 plus 3y minus 12 equal to 0. And now just solve for y because we just have one variable. So the first part is just 0 plus 3y minus 12. Move things around, you'll get 3y equal to 12. And then divide by 3 each side, and you will get something like y equal to 4. So that is actually our b value then, because that's the y-intercept. And so we can write down our equation as y equal to 1/2 x plus 4. All right, let's take a look at just one final example just to get some more practice calculating these things out. And this one's a tricky one too. So we have lines AB and CD are shown in the figure provided. So knowing that the line segments are perpendicular, determine U the missing coordinate of A. So yeah, we have basically a whole bunch of coordinates. We have one missing. All we know though is that it's perpendicular to that other line. So we see the word perpendicular, and that's going to instantly tell us, okay, we need to do something with slopes. So let's first of all take a look at those 2 points where we actually already have all the information, as in the coordinates, there's no missing like U value there. So let's just figure out the slope of CD. So M of CD, I'll just say. Well, we're given points, so we can just do our usual y2 minus y1 over x2 minus x1. So the y value of, let's say, D is -7 minus -5. That's all over the x value is 9 minus 3. And again, be careful with your subtraction here, because you're subtracting a negative number, so it's actually adding. So you'll have -2 over 6, or you could reduce that to -1/3. All right, so that's the slope of C to D. So M of, let's say, sorry, I'm just going to erase that. The slope of AB, so M of AB, well, that's just going to be the negative reciprocal. And what's the negative reciprocal of 1/3? Well, flip it over, you get 3 over 1, and positive this time, which is just 3. So we have a slope of 3 for our line AB. So now how are we going to use this? So what we can do to use this is we can again set up our slope equation. So again, we know for AB, it's going to be y2 minus y1 over x2 minus x1. But this time we can sub in the information that we have. So we have, doesn't matter which point you use as point 2. So let's start with 5 minus -10 all over 1 minus u. Okay, so what's u? We don't know. But we know that because we've already done this work about, checking it's perpendicular to CD, we know that it should equal 3, this fraction. So we can set this entire thing equal to 3. And now we can actually solve for u. So now that's what we'll do in this next part. So just to get started, let's just simplify the fraction a little bit. So we have 5 minus -10, so that'll just be 15 over 1 minus u. Okay, if we have our variable in the fraction, well, just multiply by what's in that fraction, and then we can clear the fraction. So we have 1 minus u, so we'll multiply both sides by 1 minus u. So it'll become 3 times 1 minus u is equal to, well, on the right-hand side, just be careful, because that will then cancel out, and so you're left with just 15. All right, there's a couple ways you could go from here. What I'll do is I'll expand, so I'll do 3 minus 3u is equal to 15. And then let's move the 3 out in front. So the 3 there is going to become a minus 3 on the other side. So we have -3u is equal to 15 minus 3 is just 12. And then you just need to divide by -3, both sides. So -3 divided by -3. And so 12 divided by -3 will give you -4. So that's actually the value of u, the missing x coordinate of A. Because if we have that value, that gives us a slope of 3 for this line AB, which is then perpendicular to our line CD, which had a slope of -1/3. All right, that's everything for this lesson. So don't forget to do the practice problems.